Okay, so last class we have done up to last class we have done up to let's see, we have done organometallic compounds. We have done E naught, the values of E naught. Okay, fine. All right. Already we have discussed few things. Today we'll discuss in detail. So the question was, there's a question. Let us see what is the question. Yes. Question is, okay, why is copper a strong oxidizing agent? We have already discussed. Strong oxidizing agent. Karan Tuki. Okay. So to know why copper is such a strong oxidizing agent, there is a few things that we need to know. That is, first is copper 2 plus 2 electrons. When it becomes copper, the value of E naught, তোমালোকে সকলোৱে জানা মানে E naught মানে কি? E naught means standard reduction potential. যোনে নাজানে, for them I'm telling most importantly that this SRP means standard reduction potential. Fine. So this E naught, why is copper a strong oxidizing agent? The reason is that E naught is a E naught, the value of E naught का मतलब होता है SRP. SRP means standard reduction potential. Fine. The value of E naught for this is, you all are aware that it is plus 0.34 volt. Plus 0.34 volt. মানে কি হল? যেতিয়া copper 2 plus এ দুটা electron accept কৰি ল'ব, then for that thing E naught value is 0.34 volt. এতিয়া কেইটামান বস্তু E naught মানে হেৰি বুজাই, like there is some very important specification. যেতিয়া E naught value, okay, if it is positive, okay, if the value of E naught is positive, it shows a tendency towards, tendency towards what? Reduction. Tendency towards reduction. Reduction means acceptance of electrons. Okay. So copper 2 plus is more willing to accept the two electrons to form copper. Okay. Because তার E naught value কি positive. আৰু যদি by chance E naught value to যদি কিবা কারণে negative আহি যায়. Okay, if it is negative, it means that tendency to lose electrons or tendency towards oxidation. Okay. Why is copper a strong oxidizing agent? Because of these two reasons. Okay, because one of the reason is E naught is positive. Fine. E naught is positive means it has a more tendency towards getting reduced. Okay, itself get reduced. When somebody gets reduced, it is known as oxidizing agent. Okay, copper self reduction, huh? It is undergoing self reduction. As a result, okay, because copper is undergoing self reduction as a process. Okay, as a process, it is known as oxidation. Okay, fine. As a process, it is known as oxidation. Very important. Okay. So copper is actually having a oxidation nature. This is copper is undergoing oxidation. Must remember. Okay. So copper undergoes oxidation. So what about this reaction? A reaction to ki hobo? For example, if there is a reaction, suppose the reaction is copper plus HCl giving you CuCl2 plus hydrogen gas. Normally ki hoy? Metal, when it reacts with acid, this is metal. Copper is nothing but our metal. Metal, when reacts with acid, normally they produce a metallic salt and hydrogen gas, correct? This we have learned since class 10. এতিয়া কি হল মেটালটো যদিও এসিডৰ লগত ৰিয়েক্ট কৰিছে এইটো সল্ট এটা প্ৰডাকশন কৰিলে আৰু হাইড্ৰোজেন গেছ প্ৰডাকশন কৰি আছে all right so is this reaction feasible is this reaction feasible is this reaction feasible মানে possible okay or is it going to take place okay the reason is no এইটো reaction কেতিয়াও নহয় okay no this is not possible we must always reason it why it is not possible first of all because ইয়াতে কি হৈ আছে কপাৰ টো আলটিমেটলি কপাৰ ক্লোৰাইড হৈ আছে নাই কপাৰ ক্লোৰাইড মানে what is the charge on copper +2 the charge on copper is +2 you can find it out no issues chlorine is more electronegative so x plus 2 times of -1 is equal to 0 x or value to kiman ahibo plus of 2 so copper or +2 aru yate ki 0 so tumi swa ultimately your value is going down so it is 0 it is +1 it is +2 it is -1 it is -2 so when you are going down mane loss of electrons mane ki oxidation but copper okay copper is not supposed to undergo oxidation okay copper is not supposed to undergo oxidation self reduction mane ki self reduction mane oxidizing agent oxidizing agent okay oxidizing agent not oxidation self reduction mane copper 2 plus is willing to accept electrons so it's undergoing self reduction or it's a good oxidizing agent so yate ki hoy ase copper is losing electrons you see copper is 0 over here and copper has become +2 so from 0 to +2 is it is losing electrons so loss of electrons ultimately ki hoy oxidation copper ketyao nijor logot oxidation nokore it undergoes reduction why it undergoes reduction because the value of e naught is positive aru e naught positive mane tendency towards reduction ठीक है copper undergoes reduction because the value of e naught is positive e naught jodi positive hoy it shows reduction hole ki hobo it will gain electrons but in this reaction what are you observing in this reaction just check copper is having 0 oxidation number and this case copper is having a +2 that means copper is losing electrons copper yar pra yaloke electrons loss it is losing electrons right +2 তলত গৈ আছে 0 পৰা if you see that 0 from 0 to +2 you have to move 0 to +2 you have to move down হলে কি হ'ব loss of electrons হলে কি হ'ব oxidation ultimately oxidation যদি হৈ আছে সেইটো we have to deny it that copper will undergo oxidation because the value of e naught does not say so the value of e naught is positive or positive hoৱাৰ কাৰণে it will not show this kind of oxidation reaction so this reaction is not feasible not possible or not feasible very important okay not feasible So is this reaction feasible? No, not feasible. Okay. Why? Because this copper which is here, which is showing 0, in this case it is showing +2, which is not possible. Okay. Why it is not possible? Because of the value of E naught, the 0.34. Fine. I think it is okay. If you think that you have any doubt or you have need to ask anything, please go ahead. So what is the summary? What you can write? What you can write? Just a summary, just a note. You should always make notes for yourself. Okay. Note ki likhiye pada that copper, since it has positive E naught value, it has copper, since it has positive E naught value, it has a tendency to reduce. Okay, tendency to reduce, that is, what is the meaning of reduce? That is gain of electron. Fine. Very important. So in this reaction, what happens? It is losing electrons. It reactions to ultimately copper reaction to sabo bole. Copper 0 पर to की होया copper +2. So it is losing electrons. So that is not possible. ठीक है? Fine. Let us go to the next part. So there is this same thing is asked in a different way. Okay. Is copper soluble in water? Okay, is copper soluble in water? Copper की पानी dissolve होगा नहीं? ठीक है? So it has 4 answers, 4 options, or like 4 ways to explain it. That if the value of E naught, suppose Cu +2 to copper, okay. If the value of E naught, you have to see what is the value. If it is more negative, the basic negative है, dissolves in water easily. ठीक है? E naught, if it is more negative, then it dissolves in water easily. If E naught Cu +2 Cu, if it is less negative, it dissolves sparingly. Sparingly mane অকমান dissolve হয়, বেশি dissolve নহয়. Fine. So if E naught, if it is more positive, ठीक है? If it is more positive, do not dissolve. Do not dissolve. Lot of energy is required for dissolving copper. Lot of energy is required to dissolve copper. ठीक है? Then if E naught, if it is less positive, then what happens? Do not dissolve, but some amount is do not dissolve, but some amount of energy is required. Less amount of energy is required. ठीक है? So basic and negative hole, like if the value of E naught is very negative, then it dissolves quickly. But we know that copper is like positive and not very positive, it is like little bit positive. So to dissolve copper, In water, you need lot of energy. Okay. So copper is actually less positive. Value of E naught is how much? For copper plus 2 to become copper, it is plus 0.34. It is plus 0.34. Okay. Plus 0.34 volt. Okay. So plus 0.34 volt hoar karone, like we can see that this is probably our possible answer. This is probably our possible answer. It do not dissolve directly. It requires some amount of energy to be dissolved. Okay, this is this is more positive, but we can see it is already positive, so it does not dissolve so easily. It requires a little bit of energy to dissolve. Fine. Okay. You can see what we have written. Less positive do not dissolve, but some amount of energy is required. So basically, more positive or less positive, সেইবিলাকো তোমাৰ দৰকাৰ নাই। তুমি দুটা qualification কৰি ল'ব পাৰা, classification কৰি ল'ব পাৰা। এটা হ'ল negative, negative মানে dissolves quickly, and positive means a lot of energy is required to dissolve it. That's all, simple. Just make two classifications, fine? So for if it is negative, if the value of E naught is negative, then write easily dissolves. Okay, this is the overall conclusion. And if it is positive, even if it is positive, do not dissolve easily. Don't dissolve easily. So these are the two understanding, two conclusions. Fine. Okay. There is one more explanation. Okay. Question is same question. Why copper do not dissolve in water easily? Okay. Why copper don't dissolve in water easily? Okay. So this is the question. So কি হয় বস্তুটো চোৱা যেতিয়া copper is a metal, no? Copper is a metal, so copper is like it's a network of copper. This is a metal piece. Okay? It's a metal piece. Copper whole metal এক ধৰণৰ. So metal or কি হয় metallic atom বিলাক এনেকুৱা থাকে like a network. It is there. Fine. So this is copper metal. When lot of copper comes together, they form this metallic bond between them with the help of free electrons. Free electrons মানে valence electrons. ঠিক আছে? This as a whole, it as a whole is termed as copper solid. Copper solid বুলি কয়. ঠিক আছে? All this copper together, this is as a whole because they are together, they are tightly packed, and so they are known as copper solid. If you want to break one copper away, you are supposed to give energy so that one of the copper is thrown out. Copper eta bahirot ulai ahile in network or bahirot ulai ahile. So in that case, this copper which has came out is not a solid anymore because it's an atom only. Here they are in a molecular solid network. মানে গোটেইখিনি লগ লগাই ডাঙৰ এটা নেটৱৰ্ক হৈ আছে কিন্তু যদি ভাঙি এটা কপাৰ ওলাই দিয়া এইটো এটা ইমানে সৰু এটম very very small that it can be comparable to a gasৰ নিচিনা এইটো কপাৰ atom হয় together when they are solid alone they are like gas. So the power of unity, when they are together they are solid, when you bring them or isolate them alone they become gas. Okay, so copper to prothomote ভাঙি তোমাৰ copper gas বনাব লাগিব. What does this mean? This is the network of copper as a whole, and this is individual copper atom. ठीक है? So the energy required to do this, is, you can say that it is sublimation, one kind of sublimation. It can be also said to be enthalpy of atomization. Enthalpy of atomization. So if you want to break ionic bond, just going away from the topic, if you want to break ionic bond, যদি ionic bond ভাঙি দিয়া, the energy required to break ionic bond is known as lattice energy. The energy required to break ionic bond is known as lattice energy. Fine. The energy required to break covalent bond to ভাঙিবলৈ যোনটো energy use কৰা হয়, that is known as bond energy. Fine. And the energy required to break metallic bond to ভাঙিবলৈ যোনটো energy use কৰা হয়, that is known as enthalpy of atomization. Enthalpy of atomization. Sublimation বুলি ক'ব পাৰা, but it is known as enthalpy of atomization. Fine. So to break down metallic bond, metallic মানে metal atoms বিলাক লগ লগাই যেতিয়া bonding হয়, সেইটো metallic bond. ঠিক আছে? So প্ৰথমতে কি হ'ল, copper solid. This whole chunk is known as the copper solid, and you are breaking down one of the copper outside. This is copper gas. So to do that, the energy that you are spending, this is known as enthalpy of atomization. Next step, কি কৰিব লাগিব? Copper to কি কৰিবা? Copper or হেৰি হ'ব, right? Copper will become Cu2 plus. So the energy that you are spending to remove two electrons, দুটা electron গুচাবলে যোনটো energy use কৰা হয়, that is known as IE1 plus IE2. What is IE1 and IE2? First ionization enthalpy, second ionization enthalpy, correct? IE1 is first ionization enthalpy, IE2 is second ionization enthalpy. Okay? So these are the two different ionization enthalpy. IE1 is the energy required to remove the first electron. IE2 is the energy required to remove the second electron. So total 2 plus. So 2 plus to gusa bole, junto energy diya hai, that is known as IE1 plus IE2. So prathamate ki hol, this entire chunk is broken into an atom, individual atoms. So copper solid is gas. The energy that you are using, this triangle, is the energy that you are using is known as enthalpy of atomization. Then to the gas, this is gas, huh? This to the gas, second part, you are using ionization energy and you are making it Cu2 plus. Okay, Cu2 plus কেটাও gas হৈ থাকিব নোৱাৰে, এটো aqueous হ'বই লাগিব. Okay, okay, in the initial stage it is gas. Okay, in the initial stage, because it is also gas, it is also gas. ঠিক আছে, এটা copper 2 plus to কি হ'ব? আচ্ছা, বুঝি পাইছা? copper এটো gas হৈ আছে, তুমি ionization energy দিলা, Cu2 plus হ'ব, gas হ'ব. But when it is in the water, when Cu2 plus is in the water, then what happens? When Cu2 plus is in the water, when it is in the water, then what happens? Immediately, because it has some charge, no? Cu2 plus has some charge. Then lot of water molecules are coming around it, because charge mani ki, it is having less electrons. So there is partially negative charge on oxygen. So it comes closer to the copper. So it comes closer to the copper. So it should happen, ideally, this should happen in the aqueous medium. Why? Because water makes this ions hydrated. Why it makes it hydrated? Because this ions possess some kind of charges. So A2 jetia hydration to whole, these are all water of hydration on the copper ion. This hydration, when it takes place, then some energy is released out. Some energy is released out. This energy which is released out is known as hydration enthalpy, HYD, hydration enthalpy. Okay. This hydration enthalpy, which is the energy going out, is responsible. This is like an income. Okay. This is income for the water. Suppose you are doing some work, then this is your income. So this is the money that you are getting. And then your expenditure will also come. Where is the expenditure? This energy that is coming out will be utilized by the water to break this copper atoms. That is the enthalpy of atomization will come from the hydration enthalpy. So like you got 10 rupees. From 10 rupees, you are using 5 rupees to break it down. Then IE1 plus IE2, you are using 3 rupees more, 8 rupees. ठीक है? Total 3 rupees यहाँ पे spend किया, 5 rupees atomization में spend किया. Okay, fine. So ultimately you are actually using this water. Actually copper metal को जब पानी में रखा जाता है, then enthalpy of atomization and ionization energies are, ये कहाँ से आते हैं? Water, where from water will produce this energy? You know, energy cannot be produced. It can only be transformed. So these two energies are coming from the hydration enthalpy. This is like income, and this two is the expenditure. But what happens? It is seen that the hydration enthalpy which is released, the energy which is released by water is not sufficient compared to the enthalpy of atomization. Okay? And the first and second ionization enthalpy. मतलब खर्चा ज्यादा है, income कम, right? This is the expenditure and this is the income. So hydration enthalpy is not enough. So since it is not enough, you cannot maintain it. Like this copper will not dissolve in water. कभी भी कोई भी metal जब dissolve होता है पानी में, whenever some metal dissolve in water, these are the three things that happens. Network of the metal breaks, then it is ionized, and this is the third step, hydration takes place. So this is the first step. This is the second step. Where is the second step? Yes, this is the second step. Ionization हो गया. And this is the third step. Third step में क्या होता है? Hydration. और ये hydration में जो energy निकलता है, इस hydration से जो energy निकलता है, उसी से वापस enthalpy of atomization होता है, वापस ionization होता है. If ये energy enough नहीं है, तो further atomization और ionization नहीं होगा. ठीक है? So that's why, since this is not enough, hydration energy is not enough, so further atomization and ionization won't take place. And this is the reason why copper do not dissolve well in water. So this is the reason why copper do not dissolve in water. Fine. So what is the summary that you can write? So there are two, three things that you have learned till now. And what are the things? Let us put it down. So we are doing this from some time. So summary is, the note is, number 1, copper +2 copper, इसके लिए जो E0 का वैल्यू है that is positive. Positive होने से do not dissolve in water. Okay, don't dissolve in water. Fine. Number 2. If it is, second part is hydration enthalpy is lesser than enthalpy of atomization and first and second ionization enthalpy. So these 2 points are suggestive. Why? These 2 points makes things clear. These 2 points suggest you. These 2 points are actually making things clear. Why copper? Therefore, you can write, therefore copper don't dissolve in acid or what? Fine. They do not dissolve in acid or what? If you have any question that you need to ask, please go ahead. There's a question. There's one more question. Let's see. Okay, fine. This is a different question. Question is, okay. So next is the value of E naught for m plus 3 to m plus 2. ठीक है, m plus 3 से m plus 2 होने का कोई भी मेटल अगर plus 3 से अगर इलेक्ट्रॉन गेन करता है, then it will become m plus 2. Fine. Simple as that. This is reduction. When some kind of reduction is going on. And for these values also, there are different values. Okay. Okay. So for example, there is a question that for vanadium, okay, for vanadium, or let me say for manganese, manganese from plus 3 to plus 2, E naught का वैल्यू क्या होना चाहिए? Should it be positive or negative? Can you answer? Okay. E naught for becoming plus 3 से plus 2 अगर बनना चाहता है तो E naught का वैल्यू पॉजिटिव होगा या नेगेटिव होगा? Just try to understand and tell the answer. This is the question. That E naught m plus 3, m plus 2, mn, sorry, this is manganese. मैंगनीज के लिए प्लस 3 से प्लस 2 होने से पॉजिटिव होना चाहिए, नेगेटिव होना चाहिए? व्हाट शुड बी द वैल्यू? ठीक है, दैट इज द सिंपल क्वेश्चन.
So positive.
पॉजिटिव. लेट्स सी व्हाई इट शुड बी पॉजिटिव. ठीक है, पॉजिटिव होगा, बिल्कुल सही है. इट शुड बी पॉजिटिव ओनली, not negative. Why it should be positive? Then also that also we will try to figure out. ठीक है. मैंगनीज प्लस 3 का ऑक्सीडेशन नंबर प्लस 3 है. व्हाट इज द एटॉमिक नंबर? मैंगनीज का क्या होता है? लेट्स सी. फॉर मैंगनीज व्हाट इज द एटॉमिक कॉन्फ़िगरेशन? 20 कितना होता है? ये 25 होता है, राइट? ये इसका होता है आर्गन 4s2 3d5. ठीक. सो Mn प्लस 3 कर दो तो ये क्या बन जाएगा? आर्गन 3d4. ठीक है. सो Mn प्लस 2 देखो तो क्या हो जाएगा? इट इज आर्गन 3d5. फाइन. अब देखा जाए तो प्लस 3 का 3d4 होता है, राइट? इट इज 3d4. एंड जो दिखा Mn plus 2, this is 3d5. So definitely you know that there are four reasons for stability, and the first three reasons of stability is configuration. Okay, the first three reason is configuration. So what is the configuration that makes something stable? That is d5, d3 or d10. So Mn plus 3 तो ये बनना चाहेगा ना, 3d4 से ये 3d5 बिल्कुल बनना चाहेगा. It will try to become 3d5. So to become 3d5, it needs to accept an electron. It needs to accept one electron. Suppose if it is manganese, अगर मैं इसको manganese बना दूं, so plus from plus 3 it is becoming plus 2. So since it is gaining electrons, ultimately ये क्या बनेगा? ये d4 से बन जाएगा d5. d4 से d5 बन जाएगा. सिंस ये D4 से D5 बनेगा तो इसके लिए हैप्पी बात है, लाइक इट इज अ वेरी गुड थिंग. फाइन. So since it's a very good thing, so that's why what to say, it is going to be positive. ठीक है. Gaining of electrons के लिए पॉजिटिव सिंबल दिखाना मतलब इट इज प्रोन टुवर्ड्स रिडक्शन. पॉजिटिव मतलब रिडक्शन, नेगेटिव मतलब ऑक्सीडेशन. ठीक है. ऑक्सीडेशन का मतलब क्या है? लूजिंग ऑफ इलेक्ट्रॉन्स. फाइन. So I hope you have understood this part. Even if you have any question, any problem, anything, please tell me. ठीक है. Fine. Done. Okay. Next. So let us see some trends. Okay. Trends in stability of higher oxidation state. So higher oxidation state कहाँ से पता चलता है? +4, +5, +6, +7. That is the higher oxidation state. ठीक है. Lower oxidation state कहाँ से होते हैं? Like +3, +2, +1. These are lower oxidation state. So एक जो maximum oxidation state cover करता है T block में, that is +7. Already we have seen. Yes, sir. So the maximum oxidation state that you could see here, the maximum oxidation state क्या दिख रहा है यहाँ पे? +7. So D block का maximum level का जो oxidation state होता है, that is +7 always. ठीक है. Fine. So +7 का जो oxidation state होता है या फिर +6 का या +5 का जो oxidation state होता है, ठीक है. Like for example, if it is suppose chromium does not show +7, it shows only up to +6. So CrF6 or CrF5. Suppose manganese जो show करता है, that is up to manganese, like it can go up to +6 or +5, whatever, huh? So it can show up to manganese +7. ठीक है. मैंगनीज का +7 तक जाता है, क्रोमियम का +6 तक ही जाता है मैक्सिमम. ठीक है. सो यहाँ पे दो बात है. मीडियम जो ऑक्सीडेशन स्टेट होता है, जैसे +5, +4, दिस आर लाइक हायर. +7, +6 is higher, +5 is medium, +4 is medium, +3 is lower, +2 is lower, +1 is lower. ओके. ये सब लोअर में आ जाता है. लोअर ये सब +5, +4 ये मीडियम में आ जाते हैं, एंड +7, +6 ये हायर में आ जाता है, हायर ऑक्सीडेशन स्टेट. सो मैक्सिमम जो हायर ऑक्सीडेशन स्टेट होता है हैलोजेंस के साथ, वो खाली फ्लोरीन ही होता है. ओके. व्हेन फ्लोरीन विथ फ्लोरीन ओनली सपोर्ट्स हायर ऑक्सीडेशन स्टेट और मीडियम लेवल ऑक्सीडेशन स्टेट. ओके. फॉरगेट ना द मीडियम पार्ट आल्सो. यू जस्ट कंसीडर हायर ऑक्सीडेशन स्टेट एंड लोअर ऑक्सीडेशन स्टेट. जो हायर ऑक्सीडेशन स्टेट होता है दैट इज सपोर्टेड बाय फ्लोरीन. लोअर ऑक्सीडेशन स्टेट इज नेवर सपोर्टेड बाय फ्लोरीन. ठीक है. सो दिस इज अ वेरी इंपॉर्टेंट पॉइंट. that lower oxidation state is not supported by fluorine. Fine. Lower oxidation state is not supported by fluorine. This is very very important. ठीक है, लेकिन एकदम जो हायर ऑक्सीडेशन स्टेट होता है उसमें क्या चाहिए, उसमें ऑक्सीजन का होना बहुत इंपॉर्टेंट. यू मे हैव फ्लोरीन, दैट इज फाइन, बट ऑक्सीजन इज मस्ट बिकॉज इट कैन फॉर्म डबल बॉन्ड. ठीक है, सो for higher oxidation state, only fluorine and oxygen is the supportive atoms. So compared to fluorine, oxygen can form double bonds, ठीक है. As a result, it can achieve even higher oxidation state. It can achieve even higher oxidation state. It can achieve even higher oxidation state. ठीक है, तो फ्लोरीन के तुलना में ऑक्सीजन के साथ अगर बॉन्डिंग क्रिएशन हो तो वो लोग और ज्यादा ऑक्सीडेशन स्टेट शो करते हैं. So what we have came to know, trends in the stability of higher oxidation state, that if it is making a bond with oxygen, then it may show stability with higher oxidation state. With fluorine, it shows higher oxidation state, but not so high. So these two atoms are very important, fluorine and oxygen. Fluorine और oxygen का बहुत importance है. Fluorine and oxygen का बहुत importance है, right? Fluorine and oxygen is very important because they are able to show higher oxidation state. So कोई भी एटम डी ब्लॉक का स्टेबल होता है, इसका समरी क्या लिखेंगे, that any atom of D block is stable when it forms for higher oxidation state is stable when it forms bond with fluorine or with oxygen. ठीक, this is the summary of the topic. Okay, let us write it. Higher oxidation state is shown by metals, okay, D block का होना जरूरी है. Metals is shown by metals with fluorine और ऑक्सीजन. ठीक है, फ्लोरीन या ऑक्सीजन के साथ हायर ऑक्सीडेशन स्टेट कोई भी एटम डी ब्लॉक का दिखा सकता है, दैट्स ऑल. अदरवाइज और दूसरा एटम्स जो होता है उतना इलेक्ट्रोनेगेटिव नहीं होता, बिकॉज द रीजन इज दैट ओनली, सिंस टू रीजन, ऑक्सीजन का एक रीजन ज्यादा होगा एंड फ्लोरीन, ये लोग क्या है, ये लोग बहुत ज्यादा इलेक्ट्रोनेगेटिव है. नंबर वन, वेरी इलेक्ट्रोनेगेटिव, मोस्ट इलेक्ट्रोनेगेटिव. ठीक है, फिर दूसरा क्या रीजन है, वेरी स्मॉल इन साइज, तो इसलिए ज्यादा एटम्स एक्यूमुलेट हो सकते हैं. कोई भी एटम के सराउंडिंग में बहुत ज्यादा एटम्स लाइक सर्कुलेट या फिर जमा हो सकते हैं, बिकॉज दे आर वेरी स्मॉल इन साइज. ठीक है, ऑक्सीजन एंड फ्लोरीन वेरी इलेक्ट्रोनेगेटिव एंड दिस इज अ वेरी स्मॉल इन साइज. फाइन. ठीक है, सो देयर इज अ क्वेश्चन. Question is, MnF7 exists, but you will be able to write MnCl7 do not exist. What is the possible reason? ठीक है, लिख लेना खुद से. MnF7 exists, but MnCl7 do not exist. Why it is so? Because chlorine is bigger in size and it is not the most electronegative element. Because of these two reasons only. यही दो reason है. Okay. Very electronegative and very small in size. Because fluorine is very electronegative and very small in size. Higher oxidation state जो दिखाता है, because manganese का अगर इस atom इस compound में oxidation state देखा जाए तो ये +7 होगा, यहाँ पे भी +7 होगा. ठीक है. So ये higher oxidation state में कैसे stable रह सकता है? Only when it is being bonded with fluorine or with oxygen. So here it is fluorine, so it won't show. This is not stable. ये जो compound है ये not stable में आ जाएगा. Fine. बाकी MnF7 is stable. Stable, why it is? What is the reason behind that? Since fluorine is the most electronegative element and it is very small in size. Fine. I hope after doing coordination compounds, most of you are aware like how to find oxidation number. ठीक है, इसको पहला बार सीखा गया क्लास 11 में redox reactions में, और दूसरा बार जो सीखा गया वो है coordination compounds. After that, I don't think so there is a requirement that you again there is a requirement to learn. Okay. So there is one more question, same topic के ऊपर एक और question है, let us see. What is the question? Why higher oxidation state higher oxidation state is stabilized? Why higher oxidation state is stabilized only by oxygen and fluorine? ठीक है, same question, same everything. Okay. ठीक है. Fine. So only with oxygen and fluorine. So the reason is probably number one, smaller size of oxygen and fluorine. ठीक है, smaller size of oxygen and fluorine. And number two is oxygen can form double bond. Right? Oxygen can form double bond. ठीक है. So some important points that we can write. इसको as a summary नहीं, like it's a new points. So same thing, same question. What is the question? Why higher oxidation state is stabilized only by oxygen and fluorine? Smaller size of oxygen and fluorine, oxygen can form double bonds. These two are enough. ठीक. So important question, important points, huh? As random points. Some of the random points which are very important. Number one, VF5. इसमें जो वेनेडियम का ऑक्सीडेशन स्टेट है, इसमें जो वेनेडियम का ऑक्सीडेशन स्टेट है that is +5. So this compound VF5 undergoes hydrolysis. It undergoes hydrolysis. Hydrolysis मतलब क्या? पानी के साथ reaction to give VOX3. ठीक है, VOX3. For example, VF5 या VX5 plus water, it gives you VOX3 plus 2HX. ठीक है, this is one reaction that you need to remember. VF5, when it reacts with water, it forms VOX3 and 2HX. Fine, good enough. VX5 when reacts with water, it produces VOX3 and 2HX. ठीक है, some of the important points that we write. Number two, fluorine do not support lower oxidation state. Lower oxidation state, ठीक है, फ्लोरीन जो होता है लोअर ऑक्सीडेशन स्टेट को सपोर्ट ही नहीं करता, ठीक है, दैट इज VF2. VF2 जैसा कंपाउंड एग्जिस्ट नहीं करता, डू नॉट एग्जिस्ट, बिकॉज इसमें वेनेडियम का जो ऑक्सीडेशन नंबर है वो आ रहा है +2. मैंने कहा था +1 +2 +3, ये जो है ये लोअर ऑक्सीडेशन स्टेट, ठीक है, सो लोअर ऑक्सीडेशन स्टेट होगा तो ये VF2 जो होगा ये एग्जिस्ट नहीं करने वाला, इट विल नॉट एग्जिस्ट, ठीक है। नेक्स्ट नंबर 3, एक क्वेश्चन की तरह है, Cu2I2 एग्जिस्ट करता है बट Cu2F2 डू नॉट, ठीक है, बेस्ड ऑन द सेम फंडा वी आर वर्किंग बेस्ड ऑन द सेम फंडा, ठीक है, जस्ट ये थोड़ा अलग आ गया। VX5 अगर पानी में इसका हाइड्रोलाइज कर दिया जाए तो कैसा कंपाउंड बनता है। सो Cu2I2, अच्छा ये कौन सा रिएक्शन है, ये क्या ऑक्सीडेशन रिएक्शन, दिस रिएक्शन इज इट ऑक्सीडेशन रिएक्शन, जस्ट चेक, V का ऑक्सीडेशन नंबर यहाँ पे कितना है +5, और यहाँ पे V का ऑक्सीडेशन नंबर कितना होगा, V का ऑक्सीडेशन नंबर X प्लस कर लेते हैं, VOX3 का ऑक्सीडेशन नंबर कितना होगा, V का X प्लस negative of 2 plus 3 times of negative of 1 is equal to 0. So X का वैल्यू क्या आ जाएगा, -2 and plus -3, that is minus of 5 is equal to 0. So X is equal to plus of 5, ठीक है। So वेनेडियम का ऑक्सीडेशन नंबर जो है वो चेंज नहीं हो रहा है, इट इज नॉट अंडरगोइंग एनी काइंड ऑफ ऑक्सीडेशन और रिडक्शन, ठीक है। वेनेडियम का अल्टीमेटली नो ऑक्सीडेशन नो रिडक्शन रिएक्शन, not a redox reaction, so this is not a redox reaction, ठीक, redox reaction, this is not a redox reaction, fine। Cu2I2 exist करता है but Cu2F2 exist नहीं करता है, what is the possible reason, same reason, you find the oxidation number, इसका +1 आ जाएगा, कॉपर का +1 आ जाएगा, तो +1 +2 +3 lower oxidation state, fluorine do not support lower oxidation state, simple। So copper, but iodine can support, कॉपर का यहाँ पे भी ऑक्सीडेशन नंबर +1 आएगा, ठीक है, you can find it out 2 times of X plus iodine is a halide, so it will be more electronegative, 0 क्या हो जाएगा ultimately, X is equal to plus of 2, sorry, X is equal to plus of 1, fine, good enough। Okay, Cu2 plus when it reacts with iodine negative it forms Cu2I2 plus I2, ठीक है। देखो आयोडीन एक ऐसा कंपाउंड है जिसका क्या हो रहा है, यहाँ पे -1, the value is -1, correct, this is the value over here, this is 0, so this is how much I2, this is I2, 2I2 2I2, this is 4, so 4I minus, copper is 2, make copper 2, so check the number, 2 plus is +4, ये हो गया +4, 2 into 2 plus is +4, this is 4 into -1 is -4, overall 0, this side it is also 0, right, balance reaction। तो यहाँ पे क्या होता है, कॉपर का आयोडीन जो है यहाँ पे, this iodine is I minus, right, this I minus is actually becoming I2, इसके साथ हो क्या रहा है, is it undergoing oxidation or reduction, I minus is actually becoming I2. तो ये हो क्या रहा है? So -1 से ये नीचे चला गया ना. So from -1 it has gone to 0. So it is going down. Down मतलब oxidation हो रहा है. So iodine is undergoing oxidation. You can see this question from two angles. ठीक है? Iodine is undergoing oxidation. What is happening to our copper 2+? इधर ये copper 2+ है और इधर किसका ऑक्सीडेशन नंबर क्या हुआ? +1 पहुंच गया ना. ये 2+ से +1 तक पहुंच गया है. Right? Copper is undergoing what? It is undergoing reduction. So because copper is more prone towards reduction than iodine. ठीक है? जब कॉपर को लाया जाता है आयोडीन के सामने, बिकॉज कॉपर का क्या है, इसका ई नॉट वैल्यू क्या है, कॉपर का ई नॉट वैल्यू क्या है, ई नॉट वैल्यू है तुम्हारा पॉजिटिव. ठीक है? पॉजिटिव होने का मतलब क्या है? टेंडेंसी टू गेट रिड्यूस्ड, टेंडेंसी टुवर्ड्स रिडक्शन, टेंडेंसी टुवर्ड्स रिडक्शन. So ultimately copper 2+ has reduced. It has accepted electron. कौन सा इलेक्ट्रॉन? ये जो आयोडीन के साथ नेगेटिव इलेक्ट्रॉन था, इसको एक्सेप्ट कर लिया कॉपर. ठीक है? As a result, it has become Cu2I2 and I2. Means iodine has undergone oxidation and copper, which is a metal, has undergone reduction. It has gained electrons. So I know that metals are more electropositive. Why they are more electropositive? Because उसका E naught value क्या होगा? Negative होगा. ठीक है? But copper is an exception. It is not very electropositive. It has a tendency towards gain of electrons rather than loss of electrons. ठीक है? So anti property. कॉपर का थोड़ा प्रॉपर्टी जो है अलग है. कॉपर पानी में डिसॉल्व नहीं होता, इसलिए कॉपर जग में पानी पीना चाहिए. सीधा बात है. राइट? Too much of copper is not good for health also, but you should know that water has a, when water is kept in copper vessel, it is not going to dissolve it. But if you drink copper, suppose if you put water in some plastic bottle, with heat the plastic decomposes, it comes in water. Fine. Okay, good enough. There's an important point. तो हम लोग ये random points कुछ पढ़ रहे हैं. The first was this VX5. इसके साथ क्या होता है? Fluorine does not support lower oxidation state. Cu2I2 do not exist, but Cu2F2 do not. Okay. Next, fourth point is Cu plus, copper plus. ये जो charge है, copper plus. This charge, especially this charge, which is copper plus. ठीक है? It is not a very stable oxidation state. So copper has two charges. Copper has two charges. एक है Cu plus, एक है Cu+2. ठीक है? तो ये तो stable है. This is a stable charge. This +2 is a stable charge. It's a stable charge. But copper plus is not a stable charge. ये कोई stable charge नहीं है. Not a stable charge. Not a stable charge. Okay, so Cu plus is not a stable charge, whereas Cu+2 is a stable charge. अच्छा, ये stable नहीं है, so definitely इसका life उतना long नहीं रहेगा, right? It will not have a longer life. Because something which is not stable, it would like to become stable and it would do something to become stable. Not a stable charge. So what will happen? And this is a stable. By the way, this is stable. So it would like to stay as Cu2+. No problem. ठीक है? It would like to stay as Cu2+, but as Cu+, it is not as stable, so it won't like to be forever as Cu+. If you're not stable in something, then you would like to change yourself, right? So what will happen? इसका क्या हो जाता है जब ऐसा कोई चार्ज आ जाता है, जैसे कॉपर का और क्या ऑक्सीडेशन नंबर हो सकता है? एक है +1, एक है +2 और एक है सिंपली 0. Okay, it is not any oxidation number for the normal copper metal. So this copper plus which is not a very stable charge, undergoes this reaction. Who remembers the name? Cu plus 2 and copper. ये रिएक्शन हो जाता है कॉपर का, ठीक है. So if I show you this reaction, this is in the ionic form. If I show in the molecular form, it will look something like Cu2Cl2 would undergo a reaction to form CuCl2 plus form. ठीक है. Same reaction. This is the ionic form and this is the molecular form. ऐसा क्यों होता है? और ये रिएक्शन का क्या नाम है? This, what is the name of the reaction? This is the molecular form of the reaction. This is the ionic form of the reaction. What is the name? What is the name of this particular reaction? Cu plus. It breaks to form Cu plus 2 and 0. Mind you, this plus is between these two charges. So this kind of reaction is known as the disproportionation reaction. Disproportionation. This is known as the disproportionation reaction. Fine. So copper plus, which is not a very stable charge, if it has a higher and a lower charge, which are more stable, then it would like to convert itself into them. Okay. And this kind of reaction is known as disproportionation reaction. Fine. Okay. There's a related question to this. ठीक है, छोटा छोटा टॉपिक है, मतलब डीप ब्लॉक में entirely you will get some topics like this only. Very small topic which has importance. Okay. So there's a question. What is the name of the question? Let us go through first. Question is, why copper plus 2 is more stable than copper plus? ठीक है, कॉपर प्लस 2 कॉपर प्लस से ज्यादा स्टेबल कैसे, क्यों होता है? फाइन. ठीक है, तो देखो क्या होगा. फर्स्ट इज, नंबर 1 इज हायर चार्ज डेंसिटी. हायर चार्ज डेंसिटी, इससे क्या फर्क पड़ता है? फर्क पड़ता है Cu plus 2 কি হয় সাইলবা, Cu plus 2 যদি থাকে, then more number of water molecules is going to come around it. As a result, it is going to become more stable. ठीक है, it is going to be highly hydrated because of higher charge. It is going to be highly hydrated. ठीक है, copper plus 2 is going to be highly hydrated compared to Cu plus. Higher charge density হলে কি হয়? Higher is the hydration. আৰু বেছিকে হাইড্ৰেট হলে কি হ'ব? বেছি এনাৰ্জি ওলাব, হাইড্ৰেশন এনাৰ্জি ওলাব. যিমান এনাৰ্জি ওলাব, যেনেকে ওলাই, যিমান যদি এনাৰ্জি ওলাই আছে, এইটো বস্তুটো বেছি ষ্টেবল হ'ব. বেছি এনাৰ্জি থাকিলে উৎপাত কৰিব, ৰাইট? So higher charge density results into higher hydration. Higher hydration, which makes the compound very stable. যিমান hydration হয়, ইমান hydration energy ওলাব. This is hydrated, right? This copper plus 2 is hydrated with water. So what is going out? What is going out? That is so important. What is going out? Our hydration energy is going out. আৰু যিমান hydration energy ওলাই থাকিব, যিমান hydration energy ওলাই থাকিব, ইমান বস্তুটো কি হ'ব? Stable হ'ব. ठीक है? Why copper plus 2 is more stable than copper plus? The reason is, number 1, higher charge density. Fine. ठीक. যদি বেসিকে হাইড্রেশন হয় তেতিয়া কি হব, the bonds will also be very strong with water, right? আর যদি কমকে হাইড্রেশন হয়, then what will happen, the bond will also be weaker. So this is the second point is related to the first point. Second point is stronger bond formation, stronger bond formation of copper plus 2 with what? Right? Stronger bond formation of copper plus 2 with what? This is very, very important. Okay, done. Fine. Okay, so I think we have done sufficient for today. We'll continue our classes on Saturday. So we'll stop here. If there is any question that we can take, I'll be happy to take questions. If you have any questions that you can ask. Next, I need more 2 classes to finish this. I'll do one on Saturday, one on Monday. Then it will be over. Okay. All right. If no questions, then we can stop.